Using and understanding color gradients is a key part with things like quickly reading the finite element analysis results from a heat map or communicating water quality measurement results to your client. In this video, you will learn how to create a gradient with a value cap and a legend like this for a heat map. I will first go over the general principle and then we create the legend. I understand that there might be a ready-made component for this, but if you want to learn how to apply logical operations in a script instead of gates to simplify your canvas, this might give you some pointers. Here is the first example. What this script does is that it creates hatches with colors based on a gradient that depends on the x component of the geometric centroid of a planar object on the default layer, and displays the x component of the point in an annotation dot. Here are the objects that I have drawn on the default layer in Rhino. And here is the origo of the model. As I'm using the query model objects, I can draw any geometry on the default layer and it will apply the hatch to it too. Now we are near the origo, so objects that are on the left side of this point will have a negative x value. So in general, we have the query model objects from the default layer, we get the geometries and their centroids, we deconstruct the points to get the x components, we'll check their minimum and maximum and use the script to sort out which way we want the gradient to go to. Then we use the curves as boundaries to create hatches and fill the hatches with the color that matches the value on the center point. We then use an annotation dot to display the rounded x coordinates. Here is the C# script that does most of the work. It needs a maximum and a minimum value and some number as the n parameter and two boolean toggles to edit if we want to start from the n value and if we want to move to positive or negative direction. I will display the script now. Feel free to pause the video. What this does is that I have created a set of rules and it will return the lower and upper values that I will use for the gradient component depending on those rules. Also, if I don't have an n input, it will default to 0. Currently I have set the start from n to be false and set the direction to be positive. The lower limit will now use the smallest number in the list and the upper limit will use the largest number in the list. If I change the direction, you can see that the gradient flips and now the upper limit will use the blue color and the lower limit will use the red color. You could perhaps also use an output in the C# script to reverse the list that is the gradient of colors, because now the lower limit and the upper limit inputs are not logical. But this doesn't matter as long as nothing comes between these two components and the users know what this pair does. I will change the direction back to positive now. Now what this input does is that this will either use the absolute minimum and absolute maximum values, or it will start from the n value. If I change this to true, now the gradient will start at 0 instead of minus 3000 something. So all the values that are smaller than 0 will use the lower limit of the gradient. Now if I flip the gradient, all values that are higher than 0 will use the upper limit of the gradient. If I connect a non-zero value to n, the limit value is now around here at the 3000 instead of 0. This also works if I change this value to be negative. Now the stop is around here at minus 3000. Now let's imagine that you are doing an analysis on a body of water and checking for pollutants in certain points. Here we have a map of a river that flows down through the city into the sea. Now you have placed the points correctly and added values for pollutants. We could imagine that the pollution level goes up as the river goes through the city and then down as the pollution disperses into the sea. Now this script has three parts. In the first part I am getting the points from the layer 0, 1 and getting their user text values, which in this case represent the values for the pollution levels. The second part of the script does what we just went through in the previous example. This time I want to start from 0 because I want to have the possibility of an absolutely zero pollution instead of the smallest value, which is 5. I get the gradient values and display them on annotation dots on the river. I use a custom preview to apply the colors to the annotation dots. Now to the last part of the script. This is where we create the legend. I'm using the same upper and lower boundaries for the gradient. I'm using this merge to create 2 ranges and use the second tree create a color gradient to be used as a fill style for a model hatch. The hatch is applied to this boundary curve that is the rectangle around the gradient. I could have used the query pipeline, but this time I have simply relied on the old set on one curve and have set this curve on the container. I have divided the curve to 15 parts to get 16 points. I am then creating annotation dots and again using the custom preview to fill them with colors from the gradient. You can easily use different geometries like an ellipse. I'm gonna revert this. Or you can even rotate the gradient. You can also stretch it if you want it to be smaller. This video was a little different from usual, so please let me know what you think of it in the comments. I hope you learned something again, and if you want to keep on learning, please like the video and subscribe to the channel. Thank you in advance.